Frustum of a cone.
Hello students, hope you all are fine. So we are moving to our next topic, that is frustum of a cone. Right. So what do you mean by a frustum? Let's see to it little practically, because we have a relations of a frustum and a cone. Because the frustum is derived from a cone. So let's see. See, can you all see? I'm trying to show through little practically. See, you can see this is a one cone shaped clay. I have kept it here. Yes. So this is a cone here. So what I'm trying to do is that I am I have to cut parallel. Parallel means parallel to the base. ये जो base है इसके parallel I have to cut it. So I'm trying to cut it parallel to the base. Can you all see? Yes. So when I try to cut it, you can see it is a one cone has been formed on the top. Can you see here a small cone has formed? Yes. And the base, can you see how the base is? See, in the base you can see there are two circles. One circle on the top and the other circle on the bottom. Can you all see the two circles here? Yes. So what is this? It is said this is said to be a frustum. Why we are saying this is a frustum? Because this has been derived from a cone, and also we have a two circles here, one on the top, can you all see, one on the top and the other on the base here. So similarly you can see the figure here. See, what is the figure here? This is the cone, and the cone has been cut parallel to the base. Once I cut it, I have got the top figure here and the base figure is like this. Is it or not? Once I'm cutting, you can see there are two circles forming or not on the base and at the top. Okay, see here you can see on the base and on the top also. So this is the frustum. So we can still imagine there are so many figures of a frustum here. See, can you see, can I say this is a frustum? Yes, we have a one circle here and the other circle here. This is also a frustum. Can I say this is also a frustum? Yes, because we have a one circle here and the another more circle on the top. So these all are said to be a frustum. Okay, so we will again recap the definition what we have learned here. When a cone is cut parallel to its base, when a cone is cut parallel to its base, we get two figures. Can you see the one first figure and the second figure? Yeah, one is a cone and other is a frustum. This is the definition. So in a frustum, we need to learn three formulas here. That is a curved surface area of a frustum, total surface area of a frustum, then volume of a frustum. So how we can learn this? So what I'm going to do is that I'm going to tell you how easily you can learn it, this one, because we said that there is a relation of a cone. So with the help of a cone itself we will learn. See, you know very well that is curved surface area of a cone. We will learn what is curved surface. We have already learned curved surface area of a cone. What is the curved surface area of a cone is? That is pi RL. You have already learned in the previous class. So how we can get a frustum formula from here? You also going to do put a pi. Okay, pi this. I repeat again, the formula, the frustum's formula is been derived from the cone. So the same, the pattern follows, only the radius differs. So pi, then the next has come r. But the r, if you observe in the figure, we have a 2r here. One is the bigger radius, that is r1, and the smaller radius r2. So how we are supposed to write it, I'll tell you. But for the L, it is same for everyone. Yes. So I write it the L first. Why I am not writing R? Because I have a 2 radii here. So how should I write it here? R1, we have a 2 radius. That's the reason we will write R1 plus R2. That's it. See what it is, pi RL. So we will write it pi L, and then in the place of R we are going to write it 2 radius. That is R1 plus R2. That's it. Clear everyone? Now let's go for the next one. Total surface area of a frustum. Again, we are going to learn the form. We are going to write the what? The total surface area of a cone here. What is the total surface area of a cone? We have learned it. That is curved surface area. That is pi RL plus what is the area of our circle here? See, I repeat here, the curved surface is pi RL and the area of a circle, that is pi r square. Do we learn this one? Yes. So what I'm going to do again. What did we do for the pi RL? We have written a separate form. So I'm going to write it as it is, pi So I'm now what formula I'm writing it? Now I'm writing a formula of the frustum. So I'll write it, show it here. Pi, again we can copy directly the same. Pi L R1 plus R2, because this is a pi RL place, plus pi r square. In the place of pi r square, how should I write it? You tell me. And I think now you might have got the idea also. Pi remains the same, and the r square means what we are going to write it? Which r? Because in the cone there is only one radius, but in the frustum how many radii we have? 2. So how should I write it? Here square is also there. Therefore r1 square plus r2 square. As why we are writing 2 times? Because we have a 2 radii here. I repeat again. Pi RL, so pi L and R1 plus R2, and cone formula is what? Pi RL, so we have copied same, plus pi r square, pi, and in the place of r square we are writing R1 the square plus R2 square. Clear everyone? Yes. Now let's proceed to the next one, volume of a cone. So volume of a frustum. What is a volume of a frustum? Yes, before that what we need to know? We need to know what is the volume of a cone. So you remember, my dear, what is the volume of a cone here? That is 1 upon 3 pi r square h. Yes, so we are going to write it 1 upon, frustum I am writing 1 upon 3 pi r square. We need to separate something, so better we will write it the h first and then r square. So r square, how should I write it? R1 the square plus R2 the square, and here one more we have R1 into R2, that is in multiply form. So here we have this extra here. So I will send the video how the derivation of the volume of a frustum has been derived. I will send a separate link so that you can be very clear. So let's recollect again. What is the curved surface? So what all we have to learn? Curved surface area of a frustum. Yes. Total surface area of a frustum and the volume of a frustum. How it has come, it's very clear. Only we have substituted in the place of r as a r1 plus r2. Yes, but in case you remember, we have learnt in the cone also. In the cone, that is, what is we have learnt? L square equals to r square plus h square, right? When we want to find a slant height, we used to use this formula in the cone. But for a frustum, how we will do? You have to think about it. How should we have to do for the frustum? Yes, for the frustum, what you have to do? That is L square remains L square. But there is a, what is this? Difference in the r square. So what I'm going to write here, we will not add it. We have to subtract it. What is to be subtracted? Which one is the biggest one here? R1 is the biggest one. That is the biggest radii. So R1 square, okay? We have to subtract, one minute, R1 minus R2 the square plus h square. I repeat here why we are subtracting. If you want, I can give a small explanation for this. See, my dear, this is a frustum. I'll write it little clear. Okay, so this is a frustum here. You can have it here like this. Yes, and this is said to be a L slant height. Yes, and this is the smaller radii is the biggest radii. That means we have named as R1 and R2. Okay, now this is the way it is there. But which formula we were applying it? We are applying a which theorem? Pythagoras theorem. For this, what I am going to do? I need to come very closer to the slant height. So I am taking like this. Parallel. See, this is, if this is height, this is also a height, parallel. Yes. So what happened? I need to know only this area, this part, this length. So this length is derived how? R1 minus R2. Is it or not? आप एक छोटा सा example ले लो. ये R1 जो है 8 है. R1 is 8. If you imagine that R1 is 8 and R2 is 3. Okay, R2 is 3. What will be this one? I repeat, यहाँ से यहाँ तक 8 है और यहाँ से यहाँ तक 3 है. देखो, तो 3 ये भी 3 आएगा. बचा कितना है? 5. So that is 8 minus 3. That means R1 minus R2. So same way we have done here. This is that R1 minus R2 the square plus h square. Okay, the rest everywhere we used to write plus only.